Hi, my name is Parmpreet Parmar. This is my ActivityTracker final presentation. First, to give some background on my motivation for ActivityTracker. Today, people are becoming more obsessed with their health and fitness. A healthy-oriented lifestyle is becoming common in younger people. My goal was to create a simple application for users to track and control their health. Just to give a brief summary of my project, I'm creating an activity tracking app that tracks a user's fitness data. For example, the app will track how long the user was walking and their heart rate. A user can view their data on the app and on the activity tracking Firebase database that I've created. The database stores users' activity data. The data is stored and synced in real time. There will also be an authentication feature in my app. A user will be asked to log in once they open the app. These credentials will be stored in the Firebase database. To give a better understanding of my app, the control flow diagram represents the control flow of my project. First, the user logs into their account or register if they do not have an account on the activity tracking app on their device. Then the app sends a response to the activity tracking database. During step 2, since the database stores the user's credentials, it retrieves that specific user's data, and step 3 is the database sending back a response to the app. During step 4, when the user is logged in, the app begins tracking the user's fitness activity data. Step 5, the app sends the user's data back to the database where it is stored during step 6. And steps 4 to 6 occur repeatedly as long as the user is logged in. The data flow diagram represents the flow of data throughout my project. The external entities are the users in the database, the processes of the activity data, and the authentication login, since those change depending on the user. The data can flow from the user to the database or from the database to the user. The data can either be the user's data or the user's credentials. The user data may be the user's total login steps or their heart rate. I decided to use Google Firebase for the database implementation of my app. It is a real-time database with low latency solution, real-time updates, and a cloud-hosted NoSQL database. The database will store users' credentials and user data, and only authorized users may log in and log out. This figure shows the authentication tab. Users on this list are allowed to log in to the ActivityTracker app. Each user has a unique user UID, which stores their data. This figure shows the real-time database tab in Google Firebase. The database stores a user's UID followed by their profile information, heart rate, and step data. I implemented my app on Android Studio using Java, and I tested my app on Samsung Galaxy S20 5G, and my mobile device has 12 gigabytes of RAM, under 20 gigabytes of internal storage, and a display of 3200 times 1440, and a 12 megapixel front camera, and like all smartphones, it has a step counter implemented into it already. And now I will present my demo. Step counter has a short delay of about 10 seconds. The implementation is not specificated enough to be 100% correct. The sensor checks if there's a spike in the accelerometer data and assumes that the spike is coming from a step. The spike may actually come from a step or from a user simply shaking the device. Even advanced fitness trackers, ones that use machine learning, signal processing, and other methods, still have difficulty to determine if a step is real or simply a user playing with the device. To conclude, I develop an Android application that tracks the user's step counts and heart rate. The user will need to log in through an authenticated Google account once they open the application. Once a user is logged in, they are able to start tracking those steps to measure their heart rate. The app is not perfect, but it provides users with a simple and accessible tool.